Hello everybody and welcome to another video. This video is for college algebra and we will be covering rational inequalities. You'll notice that these are very similar to polynomial inequalities in one way that we have to find the zeros, but this will add an asymptotic element, which means we also have to find asymptotes. But we will not be going through the entire graphing process for rational functions. Instead, I will show you how to use a sign chart. That's S-I-G-N, sign chart. Let's hop into the first example. I will lay the process out for you there. All right, here we go. We have our first example, and you can see, as I mentioned, that these are going to be very similar to polynomial inequalities. We still have an inequality. We will have a zero here. We're not going to try to make it too difficult for anybody. And you'll notice that we have the rational expression instead of a polynomial. So the only two things that you have to worry about finding right now are the x-intercept or x-intercepts and the vertical asymptotes, which I abbreviate VA, vertical asymptote. And those are all very, very simple to find the x-intercept, just like we did with rational functions. You'll set the numerator equal to 0 and solve, and to find the vertical asymptotes, you set the denominator equal to 0 and solve. So in this case, I'm just going to write these down because they're pretty clear. If you set the top equal to 0 and solve for x, you'll get your x-intercept to be x equals 4. So this, I lied. This is actually the 0. The x-intercept would be 4, 0. So either one of these works for our purposes, and if you do the same for the denominator, I'm going to say the vertical asymptote here, you can see that it'll be x equals -2 if you subtract 2 from both sides here. If you set this equal to 0 and subtract 2 from both sides. Okay, so we have that. The x-intercept, aka 0, and the vertical asymptote. Next, we set up a number line. That should feel pretty familiar. 2, we will have a number line with the x-intercept and vertical asymptote marked. So all that means is I'm going to put here the -2 and the 4, of course in the correct order, and I'm going to mark this as being my x-intercept, and I'm going to mark this one as being my vertical asymptote. So just like we would do over there with the rational graphs, you would see that these two things break our x-axis into 3 different intervals. Right here we have -infinity to -2. Here we have -2 to 4. And here we have 4 to infinity. And this is slightly different because I was making you only find the domain earlier. And this is not the domain, but we have to keep into account that the x-intercepts and the vertical asymptotes are on the x-axis, and therefore they both partition off the x-axis. So from here, we have our number line with the x-intercept and the vertical asymptote marked. We have our little intervals in between our vertical asymptote and x-intercept and outside of them. All we have to do then is we have to pick a number. Just pick a number in each interval like we've been doing with the rational functions. So in this first interval, I'm going to pick, how about -3? And I'm going to substitute -3 into the function that's up there for all of the x's. Oops. we go, minus 4 plus 2. So you can see I just took the number I picked and put it in for these x's. So in the numerator I have negative 3 minus 4, and in the denominator I have negative 3 plus 2. And all we're going to do is see if that number ends up being bigger than or less than 0. I mean, that's all we got to do here. So I'm going to calculate the numerator here. Negative 3 minus 4 is negative 7. In the denominator, negative 3 plus 2 is negative 1, which is 7. That is positive. Positive numbers are bigger than 0. We'll get to that in a second. So let's pick a different number here. Let's pick a number between negative 2 and 4, like 0. 0 is always simple. So here I'll pick 0. So if I substitute 0 into the function up there, I will end up with negative 4 over 2, which is negative 2, which is clearly negative. And I pick one more number over here in this interval from 4 to infinity, like, I don't know, 5. So I will substitute 5 into the function. Minus 4 plus 2, so that means I will have 1 over 7. Yep, there's no simplifying that. That is positive. Sweet. So you can see why we call this a sign chart. There are a bunch of signs at the end of it. So that was step 3. We had to pick test values. Pick test values in each interval. There we go. And then we actually had to evaluate those test values in the function. Cool. The last step, we can just shade. I mean, that's it. Step 4 is shade and answer. So this little symbol, set of symbols right here means bigger than 0. Bigger than 0 like this, or if it were bigger than or equal to 0, that's where things are positive. Positive numbers are bigger than 0. So when I shade, I need to shade anything that has a positive region. So there and there. So I will be shading to the right of 4 and to the left of negative 2. All right, so there are our intervals, and holy moly, look, our intervals are right there. You see that? And I used parentheses on these specifically because we had no equal to here. There's your answer right there. It makes so much sense to write these intervals. Please do that. All right, let me write down the answer formally here. So the answer here would be negative infinity to negative 2 union 4 to infinity. Let's take a look at the next one. All right, here we go. I have 3x over x minus 4. And this time we can see that there is a less than or equal to 0. So just really quick right off the bat, we're looking for negative values. That's what less than 0 means, negative values. So first thing first, let's find our x-intercept. That is the numerator set equal to 0 and solve for x. So here's the 0. Here is the x-intercept. Fantastic. Let's find the vertical asymptote. So that is the denominator set equal to 0 and solve for x. This is our vertical asymptote. Oops. Let's set up our number line. That'll look like this. That's a good looking number line right there. So I have 0 and 4. And again, you want to label these as either an x-intercept or a vertical asymptote. And it's going to become a lot clearer why we need to do that now. So you can see here, it divides our number line, our x-axis, into 3 different intervals. I think this one is going to be the easiest one to start with. I think this one's going to be need a little more explaining along with this one. I guess they're all going to need some explaining. All right. I used square brackets here around the 0. And that's fine because we are looking for where things are less than or equal to. Less than or equal to here. All right. Now, you may have noticed, hey, you use square brackets here, but you didn't use them around the 4s. Yes, because with the 4 here being a vertical asymptote, we can never use square brackets here. That always has to have a parenthesis around these. Because if you put a square bracket around the 4 on either side, that means you're allowed to substitute 4 into the equation. And we can't. 4 minus 4 is 0 in the denominator. That cannot happen. So the vertical asymptote will always have parentheses around the numbers here. Whereas x-intercepts will have square brackets if there's an equal to. Okay, so now we can pick our values. Let's pick -1 in this interval. We can pick, how about 1 in this interval, and we can pick, well, I guess we get to pick 5 again. Pause the video, see if you can figure out what values these give you, see if you can find out which intervals are negative, and then come up with an answer. So here's what I got with -1. I took -1 and substituted it in for these x's here. I got -3 over -3, which is 1. This number is positive. Substituted 1 in here. 3 times 1 is 3. 1 minus 4 is -3. When you divide these, you get a -1. Boom, negative. Here, I picked 5. 3 times 5 is 15. 5 minus 4 is 1. That gives you a positive 15. Okay, we're looking for where things are negative. I'm going to go ahead and say it is this interval right here, between 0 and 4. Look, there's your answer. Let me write it off to the side so that everybody knows that my answer is that. Answer, 0 to 4. Oops, that is a parenthesis. There we go. That is where this is negative. Last example, this one is slightly more oddball-y than the others. I want to give you a hint here. There's something weird about the top. There's something missing about this function. So pause the video, see if you can do it from front to back. I'll wait. No, really, I'll wait for you to pause the video. Go ahead and pause it. Try it for yourself. All right, you waited long enough. Here comes the answer. All right, I think this is enough work for now. I mentioned there's something missing from this exercise, and what's missing is the x-intercept. There is no x-intercept. If you set the numerator equal to 0 and solve for x, you have to ask yourself what x is there to solve for. There isn't one. And since there isn't an x in the numerator, that means this function has no x-intercept. As far as the vertical asymptotes go, you can factor the denominator, into these factors here. You can set each one equal to 0 and get these vertical asymptotes here, -3 and 4. From there, you can set up your number line. And you can see that it breaks our x-axis into 3 intervals. So here I go, I'm going to write these intervals out. -infinity to -3, -3 to 4, and 4 to infinity. And it doesn't matter what symbol is here. You cannot use square brackets on vertical asymptotes. So all of these numbers will have parentheses. From there, you can pick values. So here you can pick, I don't know, let's pick a -20. Why not? Let's get a little more out there. How about here we make up for that and pick 0. And here we can pick another crazy one. Let's pick 32. Sure, why not? It doesn't matter what value you pick in these intervals. I get tired of doing the easy ones, as it were. So when you substitute -20 in here for x, you end up with something like this. I think it's 4 over 408, which is equal to 1 over 102. You can divide them both by 4. Either way, the simplification of that number does not so much matter here as the sign. And so it's positive. Let's see here. What's next? We have a 0. So if you put 0 in here for x, that one ends up being a lot easier. It'll end up being 4 over -12, which ends up being negative. It does simplify, but it doesn't matter what it simplifies to because a positive divided by a negative will be negative. And lastly, plug 32 in here for x. You get this here. It's 4 over 982. And again, this does simplify, but that doesn't matter. We just care that it is positive. So what are we looking for here? We're looking for where the values of this function are bigger than 0, positive. So that would be right here. Let me color in this. And you may be wondering, and I'm just now addressing this here, why am I only shading along the x-axis instead of the graph? Well, now that I asked that question out loud, I think it's pretty obvious. There's no graph. So the only thing we have to shade here is the x-axis. So this sign chart is just another way you can do these. You could have done this with the polynomial inequalities from, I guess that was a couple videos ago now. And it would have worked just the same, except you would have only had x-intercepts to work with and no vertical asymptotes. So you wouldn't have had to worry about knowing whether or not you have a parenthesis or a square bracket around your values. So over here then, again, very quickly, I'm going to formally write the answer out. The answer is -infinity to -3 union 4 to infinity. That's it. I hope this makes sense. Rational inequalities, not too bad from polynomial inequalities. All right, good luck.